The figure below represents a triangle PQR with the initial coordinates of the vertices as P13. Then we have Q45 and R5 3.5. The triangle is rotated in the xy plane above the vertex P by an angle theta in a clockwise direction such that we have sin theta is equal to 0.6 and cos theta is equal to 0.8. We have given here the value of theta, that is the sin theta is given, cos theta is given, but the rotation is given as clockwise. So that is important here because we have given the value of sin theta. We know that the sine of minus theta is same as minus of sin theta and cos of minus theta is same as equal to cos theta. The new coordinates of the point Q you have to find out. Since here the rotation is to be carried out above the vertex P and point P is not the origin, is away from origin. So first step is to translate the point P to the origin. So when you translate the point P to the origin, in that case the coordinate of P is given as 1, 3. So we require the translation along the x direction is equal to -1 and the translation along the y direction is equal to -3. So when the point P is translated to the origin, it will become P1. Position of Q and R will also change, let labeled as Q1 and R1. Since we have a translation about the x-axis is -1 unit and along the y-axis is -3 unit, we have x1 is equal to x plus tx and y1 is equal to y plus ty. So we can calculate the new position of point P and Q. Actually, we are interested in the position Q only. We just want to confirm here that the value of P has become 0, 0 or not. So before translation, the coordinate of point P is 1, 3 and point Q is 4, 5. After translation, P will become P1. We want to confirm the value of P1 equal to 0 or not. In that case, x1 is x plus tx, that is we have 1, tx equal to -1 and we have y is equal to 3 and ty is equal to -3. So this confirm here that the position of point P1 is at origin, that is 0, 0. Similarly, the position of Q will also change. It will become Q1, which will be equal to 4. 4 plus tx is 4 minus 1 and 5 minus 3. So the new position of Q1 will be equal to 4 minus 1 is same as equal to 3. 5 minus 3 is equal to 2. Now here we want to rotate the triangle above the point P1, which is same as origin, by an angle equal to theta in a clockwise direction. So if you rotate in a clockwise direction, that is the value of theta you have to take as negative, because anti-clockwise you have to take as positive. New position will be equal to Q2 and R1 will change to R2. Whenever we have theta is counterclockwise, then the rotation matrix is given as cos theta, sin theta minus sin theta, cos theta. But this value of theta is counterclockwise. Counterclockwise you have to always take positive with respect to x-axis. Since here theta is counterclockwise and the triangle ABC is rotated in a clockwise, so each value of theta you have to replace by minus theta. In that case, our rotation matrix will become cos of minus theta. Cos of minus theta is same as cos theta. Sin of minus theta. Sin of minus theta is minus of sin theta. Minus of sin of minus theta. And cos of theta is replaced as minus theta. So this time we have cos of minus theta is same as equal to cos theta and sin of minus theta is equal to minus of sin theta, and we have given the value of sin theta, cos theta. Sin theta is equal to 0.6 and cos theta equal to 0.8, and since we are interested in Q, so this position of Q2 we can calculate as Q2 is equal to Q1 multiplied by rotation matrix R. Q2 will be equal to x2 y2. Q1 is equal to x1 y1. And rotation matrix is cos of minus theta is cos theta and cos theta is 0.8. So we have 0.8. Sine of minus theta is minus sine theta is minus 0.6. Minus of sine of minus theta. Sine of minus theta is minus and minus is plus. So we have plus 0.6. Cos of minus theta is cos theta. Cos theta is 0.8. Now as far as the q1 is considered, we have q1 coordinate is 3, 2. So x1 is replaced by 3. Y1 is replaced by 2. And we have same rotation matrix 0.8 minus 0.6, 0.6, 0.8. So we can solve this. We have 3 into 0.8 is 2.4. 2 into 0.6 is 1.2. 3 into minus 0.6 is equal to minus 1.8. 2 into 0.8 is plus 1.6. So finally we are getting x2 y2 is equal to x2 is same as 2.4 plus 1.2 is 3.6. Minus 1.8 plus 0.6 is minus 0.2. So this one is our y2 coordinate. Once you do the rotation, then you have to retranslate the point to the original condition using tx equal to 1 and ty is equal to 3. So translate to original position using tx equal to plus 1 and ty is equal to minus 3. So it will become plus 3. So in that case we have q prime, which has a coordinate of x prime, y prime is replaced as x plus tx and y plus ty. We have x2 tx and y2 ty. x2 is same as 3.6. So we have 3.6 plus 1. y2 is minus 0.2 is minus 0.2 plus 3. So finally we'll be getting this answer as 3.6 plus 1 is 4.6 minus 0.2 plus 3 is 2.8. We are only interested in q prime and our choice is 4.6, 2.8. Choice A is correct choice. A triangle ABC is to be transformed into a triangle A prime, B prime, C prime as shown in the figure with altitude 2.5 times the altitude of triangle ABC. The coordinate of point A is 10, 5, B 25, C 15, 10. So A coordinate is 10, 5, B coordinate is 25 and C coordinate is 15, 10. Since here if I directly apply the scaling along the x-axis and y-axis, scaling along the x-axis we have to use as a 1 because only the altitude we want to change by 2.5. So whatever the altitude here in the original figure, we want to increase it to 2.5 times. But since here the y coordinate of point A and point B will also change because if you directly apply the scaling. First you have to translate point A to the origin. In that case, if we translate A to the origin, the y coordinate of A and B will become 0. And if we apply the scaling for all the 3 points along the y direction, there is no change in the coordinate of y as well as coordinate of y for A and B both. Only the coordinate y of point C will change. So we'll justify here why we required the translation here, because we required here the scaling along the x direction equal to unity. So we do not want to change the base. So Sx equal to 1 and Sy we want equal to 2.5. So that the height will change, that is the altitude will change and will become the 2.5 times. If directly the scaling is done, then each and every coordinate y will change because the new coordinate x prime will be equal to x into Sx. We have y prime is equal to y into Sy. So if you do the scaling at the given position, then the y coordinate of B and C both will change. That is not required. We want only the altitude should be changed, size should not be changed, that is the base should remain same. But if we translate point A to the origin, the y coordinate of point A and B will become 0. So even you multiply 0 with a scaling factor 2.5 along the y direction, y coordinate will not change. And therefore first we'll do the translation. So first you have to translate A to the origin using tx. Now check the coordinate of A, that is 10. So you have to do the translation along the x-axis equal to minus 10 and along the y-axis is equal to -5. In that case, the a1 will become 0, 0. So after translation, a will become a1, b will become b1. a1, b1 are lying on the x-axis, so y coordinate is 0. So even you do the scaling along the y direction, y coordinate of a1 and b1 will not change, and we have c1. So in this case, x1 will become x plus tx, that is x minus 10, and y1 will become y plus ty, that is y minus 5. So we have original coordinate of a is equal to 10, 5. This point will become a1 as 10 minus 10, 10 minus 10, 5 minus 5. So it become a1 is 0, 0. That is as shown in the figure. Similarly, we can check for b, 20, 5. So we have 20, 5. It will become b1, which is 20 minus 10 and 5 minus 5. So it will become b1. 20 minus 10 is 10, 0. So what we observed here is that the AB distance and A1 B1 distance is remain same. 20 minus 10, 10, 10 minus 0, 10. Coordinate of C is 15, 10, 15, 10 will become C1, and 15 minus 10, 15 minus 10, 10 minus 5 will become C1 is 5, 5. At this stage, we'll do the scaling, and we want to increase it the height by 2.5 times. So we want to increase the height by 2.5 times. So a1 and a2, they will remain same, because we are going to use sx equal to 1. Sx is equal to 1. In that case, we have x2 will be equal to x1 into sx. So multiplying by 1 doesn't change the coordinate. Similarly, we'll use the sy is equal to 2.5. So we have y2 is equal to y into sy. That is, we have x1 into 1 is x1, and y2 is equal to 2.5 times y. But for a2 and b2, as we have shown here, the value of y2 will be equal to 0, so their coordinate will not change, and c will become c2. Since we are interested in the coordinate of c prime, so we'll only calculate c2. First of all, we have c1 is 5, 5. Now will become c2. x1 will be as it is, that is 5. y2 is 2.5 times y is 5 multiplied by 2.5. So we have c2 will become 5. 5 into 2.5 is 12.5. Now we have done the translation as an additional step. Second step, we have done the scaling, and finally we'll retranslate it to the original position. If you want to retranslate, you have to just make the positive sign of tx and ty. So we have tx you have to use as 10, ty you have to use as 5, and we have c2 value is 5, 12.5 will become c prime, which is equal to 5 plus tx, that is 10, and 12.5 plus 5. We have x prime is equal to x2 plus tx, and we have y prime is equal to y2 plus ty. So we'll get a c prime. 5 plus 10 is equal to 15, and 12.5 plus 5 is equal to 17.5. So x coordinate is not changed, but the y coordinate has been changed. So final point will be 15, 17.5. A square with a coordinate of side 1, 1, 3, 1, 3, 3, 1, 3 is to be scaled so as to give a rectangle with side 3 units by 6 unit, maintaining the center at the same position. Calculate the final coordinate of the point C. So initially we have given a square. So we have square ABCD. Coordinate of point A will be equal to 1 1. Coordinate of point B is 3 1. Coordinate of point C is 3 3. And coordinate of point D is 1 3. So this square is of side equal to delta x by delta y. So in this case we have delta x is equal to 3 minus 1, that equal to 2 unit, and delta y is 3 minus 1 is also equal to 2 unit. We want to make it here a rectangle such that the side of square AB is 2. We want to make it equal to 3 units, and the vertical side we want to make it 6 unit. For that one we required a scaling. So in this case we required a scaling along the x direction. What we desired is delta x prime divided by delta x. We want delta x prime will be equal to 3 unit, and we have delta x equal to 2. Scaling along the x direction equal to 1.5. Similarly, we have sy equal to delta y prime divided by delta y. We want delta y is equal to 6 unit. At present it is equal to 2 unit. So we have to use the scaling sy is equal to 3 unit. But the condition here is that we have to maintain the center at the same position. Let here E represent center. So this coordinate of center will be equal to 2, 2. Since we have Sx equal to 1.5, in this case we have x1 is equal to x multiplied by Sx. That is, we have Sx equal to 1.5, so you have to multiply 1.5 with x to obtain the new coordinate. Similarly, we have y1 is equal to y multiplied by sy. In that case, we have sy is equal to 3, so new coordinate will be equal to 3 multiplied by y. So using this scaling, we can calculate here the coordinate of rectangle. So we have a, which is originally equal to 1, 1. After scaling it will become 1, such that we have x into Sx, so we have 1 into 1.5, comma 3 into y, so we have 3 into y, that equal to 1. So this point will become 1.5, comma 3. Likewise, we can calculate the rest point. We have coordinate of point B is 3, 1. After scaling it will become B1. It is 3 multiplied by 1.5, comma 3 multiplied by 1, that equal to 4.5, comma 3. C, which has the original coordinate equal to 3, 3, 3, 3, will become C1 as 3 multiplied by 1.5, and sy is equal to 3 into 3. That is equal to 3 into 1.5 is 4.5, and the y coordinate become 9. And d, which is originally equal to 1, 3, will become d1. 1 into 1.5, 1 into 1.5, and we have 3 multiplied by 3 is 1.5, 9. So let's represent here the modified rectangle A1, B1, C1, D1. Now check here, 4.5 minus 1.5, that will be equal to 3 unit. 9 minus 3 is equal to 6 unit. This figure is not to the scale. What we want here is that we have done the scaling, but the position of center has been changed. Originally we have center is E is 2, 2. Now the center become E1. And this center is same as 1.5 plus 4.5 divided by 2, 1.5 plus 4.5 divided by 2. That is 6 divided by 2 is equal to 3 unit. And we have 9 plus 3 divided by 2. 12 by 2 is equal to 6. We want to shift this E1 to the original position, that equal to 2, 2. That can be done by translation. and then we are interested to know what is the final coordinate of point C. To regain the original center E, we have to translate E1 to the position E. Now, since we have to translate E1 to E, we required here the value of Tx. So required translation will be the coordinate of E that we desired is x suffix E minus the coordinate of E1, that is the x coordinate of E1. X coordinate of E is 2 and x coordinate of E1 is 3. So if you translate by -1 unit, 3 will shift to 2. Similarly, we have Ty is equal to y coordinate of E minus y coordinate of E1. The y coordinate of E is 2 and y coordinate of E1 is 6. So we require a translation on the y direction is equal to -4 unit. So using this translation we can calculate the final position of C. So the final position of C, which is represented by x prime y prime, is given as C1 plus Tx. That is, we have x prime is equal to x coordinate of C1 plus Tx. X coordinate of C1 is 4.5 plus Tx is -1. So x coordinate will become 3.5. Similarly, we have y coordinate y prime will be equal to y coordinate of C1 plus we have Ty. Y coordinate of C1 is 9. Translation on the y direction is 4. 9 minus 4 is equal to 5. So the final coordinate x prime y prime will be equal to 3.5, 5. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.